Let's do a couple questions together that you will definitely met on your Calculus 2 exam. First of all, which of the following is the solution to the differential equation dy dx equal to x squared divided by y with the initial condition y of 3 is equal to -2? This is a pretty common question that it asks you about a lot of things, like contains a lot of essential knowledges. What we can do first is cross multiply. So x squared dx is equal to y dy. So then take the derivative on both sides. Actually, I will move that around a little bit. So I'll put the y on the left side. Plus c is equal to x to the third divided by 3 plus c. And these three combine together. So y of 2 divided by 2 is equal to 3 minus 3 plus c. And multiply both sides by 6. And 3y squared is equal to 2x to the third power plus c. Okay, and then we can, at this point, you can feel free to put the initial condition into it. In order to find c, we have to do it. So this is x, this is y. So 3 negative 2x to the second power, 3 third plus c. This will be 12 is equal to 54 plus c. So c will become -42, I believe. Okay. Yep, and replug that back in the function again. So 3y squared is equal to 2x to the third power plus -42. Divide both sides by 3 will be 2 to the third plus actually minus using my calculator -42 divided by 3 is -14, and take the square root will be this. Okay, and this will be our final answer. Yeah, and because like the initial condition is in here, so yeah, remember to plug that into the function in here, and you don't have to like solve, like, I mean, you can like move it into the, like, change it into the final form before you plug the initial condition to the function to find c. But I think this way is a good way to avoid any mistakes, any potential errors. Okay, let's keep going. The function f is twice differentiable with f of 2 is equal to 1 and f prime of 2 is equal to 4 and f double prime of 2 is equal to 3. What is the value of the approximation of f of 1.2 using the line tangent to the graph of f at x is equal to 2? Okay. So for this question, what you can do is, because f of 1.2 is in between 1 and 2, so we know that f of 2 is equal to 1 and f prime of 2 is equal to 4. We know that it's increasing in here, and this is also concave up because they're all positive. And using the approximation of the tangent line, so approximate this, we can set the linear equation first. So we already know that f of 2 is equal to 1, f of 2 in here, and we have to use the f prime of 2 to set us as the slope, and x minus 2 in here. Yeah, because the x value is 2 in here, and this is our y value, so basically it's like y plus m times x minus x1. Yeah, so plug all of the numbers in. 1 plus 4 times x minus 2. The approximation will be 1 plus 4 times, so we plug the 1.9 into the function, it will be 0.6. Okay, this is our answer. Okay, let's keep going. So for this question, it's given us this cx plus d. This is a piecewise function, which is pretty normal for any calculus exam. This is for, actually, this is for x greater than 2. So let f be the function defined above, where c and d are constants. So c and d are constants. If f is differentiable at x equals to 2, what is the value of c plus d? Okay, so to do it, we need to find the c and d values separately. Yeah, because there's no relationship between these two variables, so these two constants. So yeah, so we know that x is equal to 2. Like, we can plug in 2 for both of the functions, and we can get 2c plus d is equal to 4 minus 2c. Yes, because they're equal, so we are okay to set them equal to each other. So then it will be 4c plus 4c plus d is equal to 4, and 4c plus d is equal to 4, and we know that we have to find the c first. I think it will be more easy to find. So 4c is equal to 4 minus d, and c will be 4 minus d divided by 4. And we also know that this is c, and yeah, and we can find the f prime of x first from this. Maybe it's gonna be more easy to do. C where x is less than 2, and 2x minus c where x is greater than 2. So we know that if we plug this 2 back in, we know that 4 minus c is equal to c. So negative c is equal to negative 4. C is equal to 2. Okay, so we get the c first. D will be a lot more easier. D will just be 4 minus 4c. So d will be 4 minus 8, which is negative 4. So c plus d will be 2 plus negative 4, which will be negative 2 for this question. Okay, that's pretty good. And let's keep going. So for this question, what is the slope of the line tangent to the curve? The curve is y is equal to arctan of 4x at the point x is equal to 1/4. We want to find the slope. Find slope tangent to this curve. Okay, so we can starting out by find the dy dx. So dy dx is going to be equal to 4 divided by 1 plus 16x squared. Yeah, and we can find dy dx at x is equal to 1/4 is going to be 4 over 1 plus 16, 1 16. So this will just become 1, and 4 divided by 2 is equal to 2. So 2 is our answer for this question. Okay, cool. Let's keep going. So for this question, this is let f be a differentiable function such that f of 3 is equal to 15, f of 6 is equal to 3, and f prime of 3 is equal to -8, and f prime of 6 is equal to -2. The function g is differentiable, and g of x is equal to f of -1 to f to the -1 of x for all x. What is the value of g prime of 3? Okay, this is inverse function question because we know that it already given us the relationship between g and f. So using the formula first, g prime of x is going to be equal to 1 over f prime of g of x. And so g prime of 3 will be 1 over f prime of g of 3 will be, so we know that we given us that the f of 3 is equal to 15, so 3 and 15. We know that for any inverse function, the x and y values are switched, which means g has 15, 3 for the coordinates points. So we know that g of 3 will be 15. And oh, wait a second. Yeah, because because we want to find the y value where x value is equal to 3 for g of 3. So we cannot use 15 for this question. That's a really common mistake. Oh my god, I also fell into that trap, but I want to show you the correct way to do it. Because we know that the y value and x value are switched. So we know that the x value for g of 3 is 3. So we want to know which function of f has the y value of 3, which is this. So this should be our answer. So we want to find f prime of 6, which is -2. So 1 over -2 will be our answer for this question, which is the value of g prime of 3. Okay, so don't fall into that trap as I did. That's a very silly mistake, but it's also a good lesson for you. Okay, so let us do another question. So which of the following differential equations is not logistic? I'll give you a couple functions, and I want you to do that on your own first and then watch my solution. So choice A is p prime is equal to p minus p squared. B is this. This is where k and a are constants. Okay, so feel free to pause and do it on your own first. Okay, so welcome back, and I hope you did it. So let's take a look at this together. So the question is asking us which of the following differential equations is not logistic. So logistic means that so first of all, we need to know that the least requirement for logistic curves, it has to be quadratic, right? It has to be at least a second power of the function. So we can first eliminate any choices that has linear functions, because that cannot be our logistic curve. So first, it met, and second, y times y is y squared. It also met. C is also good, while D is not, because this constant times a constant is still constant, and constant times a variable, it's first power variable. Like it's not. It's a linear curve. It's not a logistic function. I mean, linear function. It's not gonna be a curve. Yeah. And E, this is also, yeah. This format is actually our it's actually met our condition, because this is a function times a function must be function squared, so which means that this is also a quadratic function. So only choice that does not met our first condition is D, which is pretty good because we don't have to test anything else, because we already know that this is our answer. So the answer for this is going to be D. Okay, I hope you learned something from this video, and thank you so much for watching.